So what did we do in the last session? What did we do in the last session? Data pre-processing, right? So what was step 1? We have imported the libraries. We tried to read the data set. By the way, which data set are we working on? Insurance data set. And which model are we developing? Regression, ANN model for regression. Why did we choose regression for insurance data set? Because the target variable has continuous values. If the target variable has categorical values, we go for classification. Okay. After importing libraries and reading the data set, what did we do? We have done some pre-processing, which is standardization, right? Why do we do standardization? Why do we have to standardize the features? Okay, let me ask you something. Do we do standardization for X and Y also, or only on X? Only on X. Why do we do standardization? Because different values, we have so many input features, and different input features have different ranges of values. Okay, so one input feature values should not dominate other input feature, which says this is of more importance. Okay, all the input features should have equal importance when we train the model. So that is the reason we go for standardization. Okay, after doing standardization, what was test case 1 on? Shapes. Checking the shapes of what? Train and test. Okay, so this is what we have done. So this is all part of pre-processing, which is part A. Okay, now today we'll start with neural network implementation. Okay, so what do we have to do first for implementing the neural network? What is step 1 in implementing the neural network? We have to first initialize what? Weights and biases. Initialize the parameters, that is weights and biases. We'll try to build a simple neural network with only one layer. Okay, see, don't look at the task now, listen to me. The rest of the class you'll have to work on the task itself. Let me explain you for a while. Okay, now I want to develop this ANN architecture with a simple one hidden layer. Okay, so how many weights and biases do I have to initialize? 2 weights and 2 bias terms. Why do I have to use 2 weights? When I want to connect my input layer to hidden layer, I use W1 and B1. When I want to make connection between hidden layer to output layer, I have to declare what? W2 and B2. Okay. So what is step 1 in designing a neural network? We have to initialize weights and bias. Okay. Now what are these weights? Some random values. So how do you generate weights? By using which function in NumPy? Random function. Okay. Now what are these bias terms? Why is bias used? We multiply inputs with weights and then add that to a bias term, right? So how do you generate this bias? Initially the bias term would be 0. By using 0 function in NumPy, we will generate B1 and B2. Is that clear? So what is step 1 in neural network implementation? Initializing the parameters. Okay. Now the test case for this would be checking the shapes of W1, W2, B1 and B2. Okay. So we have checked the shapes for train and test splitting. That was test case 1. Here today in the first part of your neural network implementation, we'll try to check the shapes of W1, W2, B1, B2, which we are generating randomly. Okay. Again, if you don't use random state, what will happen? Your test case will not match. Why? It produces random values and that will not match with values what we have taken and put up in the test case. Is that clear? So you have to use which function? Random state by default. So define a function called initialize parameters or whatever it is as per the given theoretical explanation there, and try to define the function which will declare W1, W2, B1 and B2. Okay. So yeah, start working on it. Pranay, did you on? Yes. So are you all able to view the exercise? Is there anybody with login issues? Anybody with login issues? Please come and sit in the front so that we can help you out. So complete test case 2.
I just want to ask one question here. So just check. Just listen. If x equals to 5, y is equal to x cube, what is dy by dx? Anyone? I want to see how good you are at that, because this follow-up sessions needs derivatives. If x is equal to 5, y is equal to x cube, what is dy by dx? How many of you say 75? Please raise your hand. How many of you say no, not 75 is 125? Please raise your hand.
Okay.
Okay, how many of you say I don't know? If those who have not raised their hand, please go back, just dig into some derivatives and calculus. You should get. Answer is 75, yes. So how 75 has come, you should be aware of it. Because the going up sessions, you should know more of derivatives. Okay? Carry on with your assignment.
We want you to work on initializing weights and biases. Okay?
If KMIT body is not connecting, you might have turned out your battery saver on. So please turn that off.
Input size and hidden size. W2 is in between hidden and output. Please make sure of that. Submit again, fetch. When you are making some changes, you have to submit the exercise again. Now fetch.
Most of you have submitted. Those who are still checking the feedback, just submit and keep it. We are going to evaluate. Don't worry.
So did you all do it this way? What did we do first? First you have to define a function, and what are the variables that you pass for the function? What are the parameters that you pass for the function? Input size. They should be in that order. Input size, hidden size and output size. Okay. And then we are using a function random seed. Okay. For what? For reproducibility. Okay. And then we are defining 4 variables: W1, B1, W2 and B2. W1 for what? Generating random weights for input size to hidden size. Okay. And then adding bias term to it by using zeros function. Okay. And then what is W2? W2 is randomly generating the weights for hidden size to hidden layer to output layer, and then we are declaring bias. Return all these 4 variables. Return W1, B1, W2 and B2. Did you all do it this way? Yes or no? So we'll go with the next task. Okay, Pranay, on the next one. Okay, now we have declared variables W1, B1, W2, B2. The next would be you have to define activation functions. Okay. So what activation functions do we use for regression now? So we have one input layer, one hidden layer and one output layer, right? So for input, what do we do? So what activation functions we have to use? For classification, we use what? We use sigmoid, okay? For regression task, for the hidden layer, what do we use? And for the output layer, what do we use? Loss function, mean square array is loss function. I'm talking about loss functions. I'm talking about activation functions. So we'll define activation functions. Pranay, open the task. Okay? Yeah. So are you all able to see this task now? So what are you supposed to do? In this task, you're supposed to implement the fundamental functions used in neural network for what activation functions? ReLU and sigmoid. Why do we use ReLU and why do we use sigmoid? ReLU is for the hidden layer and then sigmoid is for the output layer. Okay. So why am I using sigmoid for output layer here? For regression, why am I using sigmoid? Yes? Why are we using sigmoid for the output layer? What does sigmoid activation function do? Yes? Anyone from here? You can work on the exercise, but meanwhile you give me the answer. Why do we use sigmoid activation function for the output layer and why ReLU for the hidden layer? Yes? Anybody? Sigmoid? No. Yes? To stop gradient vanishing? No. Why are we using sigmoid at the output layer? Yes? The output variable has continuous values. So, what does sigmoid do?
Sigmoid function because Boolean option.
No. Is sigmoid required? See, look at the task. What are we asking you to do? Correct. Okay. We are asking you to implement the fundamental functions used in neural network. That is, we are asking you to derive ReLU activation function. Okay. So, do you see sigmoid there? Only ReLU. Why? In the last session only I told you, you have to decide which activation functions to use and the importance of each activation function. Okay. So, why are we using ReLU here? Is the question. Why ReLU? What are the 4 activation functions? Sigmoid, TANH, ReLU, softmax. Correct. Okay. So, why do we use each activation functions and why am I using ReLU here? You can easily write the function for ReLU, that is okay, but you should know why are we using ReLU here. Even if it is wrong, it's okay, you can say. To introduce non-linearity. Is that correct? To introduce non-linearity. Why non-linearity here in this case? To get more accurate output? No. For continuous, we take ReLU, that is okay. But why is the question? We have multiple. Okay. You are almost near. You heard the term vanishing gradient problem, that is okay, that is correct. But what is this non-linearity, and for regression why are we using ReLU, that is important. Yeah, so we'll just have a quick recap on activation functions again. So first thing that you told is correct. Why do we use activation functions? Basically we use activation functions because they introduce what? Non-linearity into the models. Okay. So why do we need non-linearity actually? Why do we have to introduce non-linearity? Because we often deal with the networks which will learn and identify the complex patterns in the data, right? So when you want to do that without activation functions, basically, how does the neural network behave? How does the neural network behave without activation functions? If I just take input, output, input, hidden and output, what will happen if I don't use activation functions? It will simply act as a linear model. What do you mean by linear model? Same values would be passed, right? So without activation functions, that would basically behave like a simple linear model. So what will happen if it behaves like a simple linear model? It will not be able to predict. It will not be able to predict the result. Okay. So basically, to capture the patterns, underlying patterns, or to understand what exactly is being done inside, we use what? Activation functions. Okay. So we have seen 4 different slide change. If you don't use activation functions, your network will simply function like a linear model where the output will not be as predicted, or simply it will just function as take the input and pass the same at the output layer. Okay. So we have seen 4 different activation functions. One was what? Sigmoid, TANH, ReLU and softmax. Okay. So why do we use softmax? When we go for multi-class classification problems where you have multiple classes in your output layer, we use what? Softmax functions. When we go for multi-class classification. Okay, when it is binary classification, what do we use? Sigmoid. Why do we use sigmoid for binary class? Because it maps the values to the range in between 0 to 1. Okay. Now, apart from this sigmoid and softmax which we have used for the binary classification task in the last session, we've also discussed about two other activation functions which were what? Tan H and ReLU. Okay. So, what is tan H? That maps the values in the range of what? -1 to 1. Okay, we've also discussed the drawback of using tan H too. Okay, so when you use this tan H, that centers the output which can sometimes lead to better convergence than what? Sigmoid also we have seen. Okay, now why do we use ReLU? It introduces what? Non-linearity, that is correct. But how does that function? Introduces? Vanishing gradient problem is reduced in ReLU, that is okay. So but what does ReLU do? It introduces non-linearity by outputting the input directly if it's positive or else 0 otherwise. Is that clear now? Yes or no? Okay, now next slide. Okay, we'll see that. Okay, so this is sigmoid activation function which we use for binary classification. Okay, so we put up a threshold and we classify below threshold values to 0, above threshold values to 1. So that is the reason, as we have only two possibilities, 0 or 1, depending on these values we use sigmoid. Okay, next. Now look at this. We basically have this tan H function which maps the values from -1 to 1. But what is the problem with this tan H function? Next. Okay. What is the problem with this tan H function? When you calculate the derivatives, when you do back propagation and when you are calculating the derivatives, as you can see in the figure there, for tan H and sigmoid, the derivatives values are more deviated. Okay. So with this we have vanishing gradient problem. Okay. So that is the reason, in order to avoid vanishing gradient problem in tan H, we go for what? ReLU activation function. Okay. Yeah. So this is vanishing gradient problem, because the smaller values of derivative lead to very slow learning, or very higher values also leads to very slow. Only some mid-range values only will have proper output in respect to tan H. Okay, so that is the reason, in order to avoid this, we go for the next activation function, which is what? ReLU. Okay. So what do you see here? What does ReLU do? It maps
Any input below certain range to 0, the rest to
any input below 0 to 0 and above 0 to the x, not 1. Above 0 to the x input. Okay. So why are we using ReLU for regression now? You tell me that. This is what ReLU does. You know about this. Okay. Now why am I using ReLU for regression model? Yes? I didn't get you.
the cost can't be negative.
The cost can't be negative. Okay. And any answers? Why are we using, this is ReLU, you know what is ReLU, but why am I using ReLU for regression model for the regression model? That's okay, you can.
To get appropriate output for the input.
To get appropriate, see, for every model we want appropriate output for the input.
We'll give input command, exact output will come, like y equals a plus b.
It classifies
More
two different types,
precision.
ma'am. Below 0 and above 0. Positive values and the other 0 values. So it will convert less than or 0 to zeros, and positive values directly reflected to the output.
No. You are explaining ReLU activation function only.
Then what is your question, ma'am?
Yes? It's not just limiting to 0. We have different range of values in our target. Okay. So all those range of values has to be processed, and the output should be what? The exact same input. I want my values which are there in the target to be produced exactly. Okay. Correct. Yes. The activation function does that.
The graph is completely linear, where is non-linearity?
I didn't get you.
Like in tangents and sigmoids, we could see that non-linearity.
Yes.
But there is no non-linearity at all.
No, when we do the back propagation, when we go for that, when you're adding the derivatives of that, then it will calculate the non-linearities for each and every weights and bias. I'm just declaring the function here. When you add that with weights and biases in the forward propagation, then the non-linearity comes into picture. You have to take weights, biases, and then apply the function. Then the non-linearity comes. See, you're not taking any input as of now. You're just defining the activation function. When you implement that in the forward propagation and use that along with weights and biases, then the non-linearity comes into picture. Got it? Okay? Yeah. Now start working on it. Derive the ReLU function and also the derivative of it. Why do we want the derivative of ReLU function? For back propagation. Exactly. See, once you are done with defining activation function, we'll also do forward propagation. Okay? So once you are done with defining activation function, you are supposed to do what? Forward propagation. So what do you do in forward propagation? What do we do in forward propagation? Yes? Multiply what? Inputs with weights and add bias term with it, and then apply activation function to what? The summated, weighted summation. Yes, correct. Okay, try working on forward propagation. Once you are done with defining your activation functions and finding the derivative, you have to implement forward propagation. You have to pass your input data through the network layers and then apply activation function to that. Z2 A2. What is Z1? What is Z1? Dot product of X and W1 where you add bias 1. Okay. Now for this Z1 we apply ReLU activation function which will be A1. Okay. So what is Z2? Dot product of what? A1 and W2 wherein we add B2. Now what is A2? Not ReLU. Here we have to apply identity of what? Identity of Z2. See, Z1 is the summation of the dot product of X into W. After that we apply activation function. Now this would be the dot product with W2 which is Z2. Plus B1, ReLU of Z. Sir.
So let's stop this.
Okay.
You can show the solution now, discuss the solution.
Okay.
And we'll wind up the session.
Okay.
We are stopping the activity. Don't worry, we're going to stop. We'll see. We'll learn something.
Use sigmoid. Sigmoid is used for classification only. You're supposed to use ReLU.
Yeah, we have stopped it. Just look at the solution. What is the approach?
Okay. So in the first block we have defined our activation function, right, which was ReLU. Okay. So I'll say ReLU and then I'll also define the derivative of ReLU. Okay. So how did I define ReLU? By using np dot maximum of what? 0 comma z. Z is the parameter that I passed into ReLU. Okay. I am also finding the ReLU derivative which I'll use for back propagation. Okay. And then I have defined an identity matrix which I'll be using for Z2 after I take my activation function. Okay. Now, how do we do forward propagation? We are supposed to define 4 variables. Z1, A1, Z2, A2. What is Z1? What is Z1? W1 X plus B1. So np dot of what? X comma W1 plus B1. After I do this Z1, I am going to apply ReLU for Z1 which would be A1. Okay. So how did we do that? Look at this. So I am defining a function called forward propagation wherein I am passing these parameters. What are the parameters? X which is input, W1, B1, W2, B2. Using these parameters, now I will define my network in the forward propagation. Okay. So I say Z1 which is what? Dot product of X, W1 plus B1. Now I will apply activation function to this Z1 and I call it as A1. So A1 is what? ReLU of Z1. This is for the hidden layer. I am done. Now I will define Z2. What is Z2? Dot product of A1 into W1, that is from hidden to the output. So I'll take dot product of A1 after the activation function. A1 is applying the activation function. So A1 into W2 plus B2. Now here when I am declaring my output here is A2, I'll apply the identity function. Is that clear? So A2 would be what? Identity of Z2. Okay. So I'll return what? Z1, A1, Z2 and A2. Okay. See, few of you when you are initializing forward propagation function, in the brackets you have taken W1, W2, so instead of W1, W2 you have taken Z1, A1, Z2, A2. I have seen few people, don't do that. See, the parameters that you require for defining this forward propagation is input, weights and biases. Is that clear? Using inputs, weights and biases, you are supposed to define Z1, Z2, A1 and A2. Got it?
If you don't have any questions, so
రిటర్న్ అవుతుంది కదా ఇన్స్టెడ్ ఆఫ్ దాట్
go
ఇంటూ
to the
ఈక్వల్స్ అది జెడ్ పెడితే అయిపోతుంది
previous
కదా
classes, recollect what was the challenge.
జెడ్ వెళ్తుంది
అరేగా మిస్ మ్యాచ్ అవుతుంది కదా నాన్న.
Is
మ్యాపింగ్ అయినవన్నీ ఒక జూపిటర్ నోట్బుక్ ఓపెన్ చేసుకొని ట్రై అబ్జర్వింగ్ ఇన్ ద